Great. So good morning, guys. Thank you for coming. Before we get started talking about projects, I want to kind of give you guys a little bit of intro as to who I am and some of the things that I do. So here I am. I'm a total horse girl. Love horses since I was like, yay, hi. Even though horses are my favorite, I love pretty much all animals. I've had cats, dogs, turkeys, you name it. I probably try to keep it as a pet. I work here in OIT with the BITS program. My specific track is PC deployment. I absolutely love my job there and probably love it a little too much. You'll see why I say that here. I'm a CRT major and I have two minors. One is in web development and the other one is in computer science. So a little bonus fun fact about me, I'm a workaholic. I never really leave work. Mentally, I'm just kind of always there. Is that healthy? I don't know. But after I get home from work, I'm constantly thinking about my day, reviewing things that could have gone better, smoother, maybe just faster, even more just comfortable for me or the employees that I work with. And this is why most of the projects that you'll see here today are going to be centered around improving the workplace environment for employees through doing research-centered design solutions. I really want to emphasize the research-oriented portion of this because I am a firm believer that your solution should not be worse than the problem. And I think the only way to enforce that is to do research about your constraints, your problem itself, and make sure that you fully understand what you're getting into before you start trying to solve a problem. So the first project that I did, I pretty much started making work-related projects right out the gate. This was a project I did for CRT 101. It is the step-in store. It was a height adjustable step stool that you could store things inside of because it was completely hollow. To give you a little bit of background of why I even made this thing, like I said, I work in PC deployment, and that means we have a lot of expensive computers and equipment that are on tall shelves. Let you guys in on a little secret. I'm short. I don't know if you can tell, but I'm not the tallest person in the world. So a coworker and I, he was about 5'2", and we were just struggle busting it. Like every time we'd get a computer, we'd just about drop it on our head. So I was like, yeah, that could come out of my paycheck. So I decided to do something about it. So the first thing I started to really research was just spatial dimensions in general. So I wanted to make sure that obviously it fit within the office space. Also, he was about 5'2", so I figured that if I can make a 5'2" person reach the tallest 7.5-foot shelf, I've done my job well. So the highest setting gives you about an extra 20 inches in height, and so that takes a 5'2" person and makes them 6'10". And then we also have a shorter shelf in the office, and so I don't want to be overkill. So that's why the first setting is just a foot. That way a 5'2" person can easily get to that 6-foot shelf with just an extra foot. The reason it collapses down in on itself is because I wanted it to be able to tuck away under tables. That way when you got done with it, you could just slide it under the table and you were all good to go. So we don't have a lot of space in the office, so that was really important just to make it disappear with needed. On top of that, I made it hollow for storage because I thought, okay, why not make this part of the environment to where you could actually use it for storage and it's not just taking up space. So we can store cables or adapters or anything that we really need to on the inside. And of course, I wanted to make sure that this was safe for people. So we did some user testing. I was really proud to find that, excuse me, that at the highest setting, it was able to hold comfortably 250 pounds and no creaks, bends, or any weird noises. The next project that I did was probably one of the most research-heavy projects that I've had to do. And this was because it was not improving an environment for my own workplace. It was improving the environment for the Hackberry lab assistants. So Grace Pleasant and I, we started doing this project to see if the laser cutter was ventilating as well as we originally had it because it had been rerouted and moved. So I'm not a chemist, so trying to figure out what we were even looking for was kind of the first thing that we had to research. So it turns out the most hazardous particles that commonly come out of a laser cutter are just fine dust particles, and they call them like 2.5 microns in diameter, and that just means it gets stuck in your lungs and not real good for you. So after we figured out what we were looking for, we did an environment study just to where we can see for about an hour just how people were interacting with the laser and how the lab assistants were interacting with it. So we saw habits like where somebody would take a cut immediately out and not let the laser cutter clear. So after we did that, we deployed our sensors. We cut the study in two parts. We did one half of the study where the sensor was on the outside laser to see what we were breathing in, and then the other one was on the inside of the laser where we could see what was being ventilated out and do a comparison. So once we got our data, we were like, cool, numbers, we have numbers. What does that mean? What is good? What is bad? So we actually did some research with OSHA, and the unfortunate part about OSHA is they use acronyms everywhere, and I was like, I have no idea what this means. So I actually reached out to Dr. Thomas Shipman, and he teaches the OSHA class here, and he was such a great help in giving us how to do our own time-weighted averages, how OSHA compares their exposure limits, and just what some of the acronyms meant. So by the end of it, we were able to take all of our data and put it onto a website and come up with these really cool charts and graphs that the user could interact with. And every chart that we had answered a specific question. And then it also had a corresponding pie chart that would show us how above or below the exposure limits we were. So by the end of it, we were able to kind of come up with some safety practices. So we decided based on our data that the safest practice around the laser cutter was to let the laser cutter clear for about 30 seconds before opening the lid after your cut. And then also don't turn the ventilation off immediately. Let it run for about 2 minutes. That way it can get all of the dust particles out and you don't end up filtering some of them back into the lab. Yes, I know it's annoying and loud, but please, for the love of your lungs, do it. All right, so this next project I actually did for my senior exit hackathon. It was pretty fun. It was to cut down on the time that I at work spent on writing emails. But like I said, I love my job, but writing these emails are really, really repetitive, and they're the same email over and over. So we actually have templates for them, and we have all the user information and user database. So the unfortunate part is that we still have to copy and paste all of the data into the template, and that's just time inefficient and it's annoying, and it can take upwards to about 45 minutes out of our day, which when I only work for 2 hours, that's a large chunk of time that I'm not doing other things. So I decided to make a script that did that for me. I was originally going to write the script in Python, but then I started to think I wanted it to be able to run on any PC in our office. And so I decided, you know what, I'm going to use PowerShell, because PowerShell is natively hosted on every PC. You don't have to install it, and it's just there. So another thing that I started to think about is I wanted to make this usable for everybody in the office. And I'm a computer science minor, so I'm okay with coding. But the others in my office, some of them are not as experienced with coding. So I decided to make a graphical user interface. That way they could adjust variables as they needed to without actually having to go in and adjust, find whatever I wrote in the code and adjust it from there. So it would, the way this kind of worked, it would ask you for your name. So it could sign emails down at the bottom for you. It would ask you for your CSV path and then your kind of a destination path as to where you wanted backups for emails to be stored. And then it would loop through the CSV file and paste all of the information into the template. And then it would open a Outlook draft for you with all of those templates. That way you could just hit send on each email and you were good to go. So this cuts down a 45-minute process into about a 5-minute process. So I was pretty happy with that. So the last project I'll talk about before I talk about my capstone is a standing desk. And I actually did this for a gift for my boss. In OIT, we sit a lot behind a desk, and sometimes we want to be able to stand. And my boss has this bench that's about 30 inches. Well, at the time, he's 6'4", so he always was doing this weird C shape as he was trying to use it. And I was like, that can't be comfortable. So I decided to make him a standing desk where he could stand and work. So I did some research on comfortable viewing angles for a 6'4" person. And I know that for a viewing angle, 15 degrees below parallel is where you kind of want it to be. I also did just some research on the space constraints because I wanted it to be able to fit within his office. And you'll notice that it's a flat pack design. The reason I did that is because OIT is very famous for moving every 2 years. So I wanted it to be something that where hardware wouldn't get lost. It would just be something he could pack up and store away and you would be good to go. It's pretty light too because it's made out of MDF. So it's not something that's going to weigh 1,000 pounds if he tries to move it. So it turned out really nicely. It's still in the office today. I painted it to match his office. He uses it. It's kind of cool because he doesn't have the C-shaped posture anymore, which is very nice. So I did a little bit of in my design, I modeled this in Fusion 360 and then cut it out on the crawlbot here. The reason I modeled it in Fusion 360 is because I really wanted to parameterize everything. That way I could adjust as I did research. So yeah, I was really happy with how this turned out. So, all right, well, that brings me to my capstone. My capstone is a little bit different than my previous projects. I actually just started to sell laser engraved charcuterie boards. And I started a business called Simply Serving Boards. And the goal of this business was to make some profit that I could donate to the Davy Shelter here in Rome. So I'll walk you guys a little bit through the process of how I make the boards. The first thing I do is I'm able to get a design from either the customer or I just make a design myself. And I do raster engraving. And the reason that is bolded and italicized is because I'm super, super excited about this. Before, when I was kind of making the boards, I would use the big laser cutter here, and we were able to do like an outline of images, and that was cool, but it always felt like it was really missing something. So with the raster engraver, I'm able to fill in the images, and it makes it just look so much better. So the fun part was setting up the raster engraver, because this little guy had been sitting in the lab for 6 years and was just covered in dust, and the parts and pieces were all over the place. So Zane and I were able to get this thing back up and running. We started out with zip ties and water tubes, trying to get it to cool. And so I've actually learned so much through this process. I've learned how to align the laser on my own, and just how to do basic maintenance with it, and how to use the software. The one downside about the software is it's kind of old, so it doesn't have like an auto centering feature on it. And if you know me, I hate doing repetitive math over and over, and I'm really bad at it. So I actually made myself a Python script that would align the image on the board for me. So it would take like your frame, and then it would take the image size, and then it would align it in the center for you. And that would, help me so much because it cut down on time and I wasn't doing bad math. I also had to do some improvement on the oiling process because, again, when I did this before, I would oil the board, wait for 30 minutes, go back, oil the board again, wait for 30 minutes. And by the time that ended, my hands hurt and they're disgusting. I was oil everywhere. So I actually got turkey brining bags and just set the boards in those turkey brining bags. That way, one, I could reuse the oil. Two, the boards actually got like a smoother and more even coat of the oil, and they just looked a lot better. My hands didn't hurt. So progress so far is I've sold 19 boards this semester, and I've got $441 that I'm hoping to donate soon. Just waiting on a check from Barry still. They're being kind of slow, but we'll get there eventually. So what's next for me? Master plan is that I want to enter into the IT field as a PC technician. I'm working on getting the second half of my A+ certification, and then after that, I hope to get a Network Plus and Security Plus certifications. And this way I can eventually slide my way into being a systems administrator. What I'm currently doing is just continuing my interview processes that I've got for a couple jobs that I've applied for. I'm just going to keep applying for jobs, see what happens, and then maybe do some research into jobs outside of the Rome area. So I know that was a lot of information in a short amount of time. So please, if you have any questions, let me know.